6.2 practice B, couple practice problems. Product of powers for number 1, so we're going to keep the base the same. We're going to add the powers together. So it's 7 to the 1/3 plus 4/3. So this final answer is going to be 7 to the 5/3 power. Problem number 2 is quotient of powers. Bases are the same. So in this case here, we're going to subtract the powers. Bigger power in the numerator, so the answer stays in the numerator. So this ends up at 4 to the 1/3 powers. Power of a power, so for this one here, we're going to take 6 to the 2/3 power, and that's being raised to the 3/4 power. So this is 6 to the 2/3 times 3/4. So you can do some cross canceling, or with fractions, when you multiply fractions, you just multiply across the top, multiply across the bottom. 2 times 3 is 6, 3 times 4 is 12, 6/12. So this is going to be 6 to the 1/2 power. Problem number 4. Okay, this is going to be power of a product. So we have 5 to the 1/4 times 3 to the 1/4. So we are going to group this here as 5 times 3. Both of those raised to the 1/4 power. So for a final answer of 15 to the 1/4 power. Problem number 5 is going to be the 4th root of 2 times the 4th root of 8. Okay, so since they are both having the same root taken to them, so this is going to be the 4th root of 16. 4th root of 16 is going to be 2. Another way to look at that is 4th root of 2, that's 2 to the 1st power, times the 4th root of 8. 8 is 2 to the 3rd power. We can change this and write this as 2 to the 1/4 times 2 to the 3/4. And then we just add the exponents. 1/4 plus 3/4. That's 2 to the 4/4, which is 2 to the 1st, which is just 2. So the same thing we had for the first time. And then we have quotient of powers. So we come up here, we could just take this and make this the 4th root of 192 divided by 6, and that's the 4th root of 32. Okay, now the 4th root of 32, are there any perfect 4th roots that go into 32? Sure. 16 times 2. 16 is 2 to the 4th power, so the 4th root of 16 times the 4th root of 2. We can do this. The 4th root of 16 is 2. We can't do the 4th root of 2, so we leave this as 4th root of 2. And that's very important when you write that answer, that you're writing the index in there, that is 4. Okay, so that's the next 3 problems. All right, so we're going to take this, we're going to rewrite this a little bit. We're going to make this 11 to the 1st power divided by 11 to the 1/4 power. Okay, so bases are the same, so we are going to subtract the exponents 1 minus 1/4 for a final answer of 11 to the 3/4 power. Okay, so up here we got cube root of 7 times the cube root of 49. So we can multiply 7 times 49 because they both have the same index in here. 7 times 49 is going to be 343. Cube root of 343 is 7. Another way to look at this is that's 7 to the 1st power times cube root of 7 to the 2nd power. So that's 7 to the 1/3 times 7 to the 2/3. Bases are the same, so we're going to add the exponents 1/3 plus 2/3, which is 3/3, which is 7 to the 1st, which is just 7. Same answer we had right up here. So problem number 9, we have power of a power. So we're going to take 3 to the 3/2 power times 2, okay? You can multiply across the top, 6 over 2, which is 3 to the 3rd power. If you have a number like this, then you should just simplify this. 3 to the 3rd power is going to be 27. Okay, there's the next 3 problems. 54 divided by 64 to the 1/3 power. So I'm going to split this up. I'm going to take the cube root of 54 over the cube root of 64. 64 is a perfect cube. It's 4 to the 3rd power. So I know that the bottom is going to end up being 4. Now the top, I think, are there any perfect cubes that go into 54? And I know that if I do 27 times 2, 27 times 2 is 54. 27 is a perfect cube. It's 3 to the 3rd power. So I'm going to take the cube root of 27 times the cube root of 2. Okay, cube root of 27 is 3. This I can't do. I can't take the cube root of 2. So keep that. Remember, leave that index in there, over 2. And then we put in 4. So it's 3 times the cube root of 2 over 4. All right, problem number 11. So I'm going to take this, both the 4th roots. I'm going to take this and write it like this. And that's going to become the 4th root of 16. And we know the 4th root of 16 is 2. All right, problem number 12. Okay, so I'm going to rewrite this a little bit. This becomes the 5th root of 5. This is the 5th root. I'm going to write 27 as a power, 3 to the 3rd power. So we have to rationalize the denominator, much the same way you did previous problems when we had something like this. 8 divided by radical 2. Okay, I'm just going to show you an example of how do we rationalize that denominator. You're not allowed to have rationals in the denominator, so we multiply by root 2 over root 2. Now, there's a 2 in here and a 2 in here. So on the bottom, what's really happening is you've got this 2, but this becomes 2 times 2, which is 2 squared. And these two 2's cancel each other out. So the square root of 2 squared is just going to be 2 on the bottom. On the top just stays as 8 root 2, 8 root 2. Of course, you would then cancel this out if possible, so this becomes 4 root 2. But let's get back to this problem. So in order for me to cancel out this radical, I need to have 5 3's on the bottom. So I need to add 2 more 3's on the bottom. I'm basically adding the 5th root of 9, but I'm going to write it like this. And on the top, I'll write it like this at the same time. I'll change that in a second. So the top becomes the 5th root of 5 times the 5th root of 9. And on the bottom becomes the 5th root of 3 to the 5th power, because we're adding these exponents, 3 plus 2. So the top becomes the 5th root of 45. Same way these 2's cancel out over here. This one here and this one here canceled out and just left us with the 2. These 5's are going to cancel out. 5th root of 3 to the 5th is just going to be 3. And that's your final answer. Back to product of powers. So we're just going to add the exponents. So this becomes x to the 9/3, which is just x to the third power. Okay, this one over here is supposed to be a 2 in here, so this becomes x to the 2/5 raised to the 1/2 power. So it's x to the 2/5 times 1/2. They're going to cancel out, so this just becomes x to the 1/5 power. Now you can leave it written like this, or you could change it and write it like this if you want, but this is perfectly okay. All right, so we're going to do x to the 1/2 times 2/7. Again, I'm going to cancel rather than multiply the tops and multiply the bottoms. Now I'm going to go x to the 1/7 power. Okay, there's our next three. I'm going to take this 1/3 power, I'm going to bring it through. This is x squared times 1/3. And this is going to be 27 can be written as 3 to the 3rd times 1/3. These are going to cancel out. So this becomes x to the 2/3 on the top, 3 on the bottom. Okay? 17. I'm going to take the cube root of 16 times x to the 4th. So let me show you this because this is going to come up later too. Cube root. Are there any perfect cubes in 16? There are. It's 8 and 2. And then I'm going to write x to the 4th as x to the 3rd and x. Okay? Let me just show you this. This is 2 to the 3rd power times 2 times x to the 3rd power times x. Okay, so this 3 and this 3, they're going to cancel out, which gets me this 2 coming outside. This 2, you're taking the cube root of 2. This 2 has to stay underneath. Now we're taking the cube root of x cubed, so that's x. Then you're taking the cube root of x. That can't be done, so that stays under there. So it becomes, okay, that's our final answer. Make sure you leave that index in there. All right, so let's come over here. This becomes 1 over x to the 3rd, right, to the 2/5 power. I'm going to bring this 2/5 power to the top, so 1 to the 2/5 power stays as 1. Then I'm going to bring the 2/5 powers to the bottom, and that becomes x to the 3rd times 2/5. So it's 1 over x to the 6/5 power. Okay, problem 19. We are going to take the powers and subtract the powers because the bases are the same. So final answer, x to the 3/5. Number 20. Cube root of 64, we know is 4. Cube root of x to the 3rd power, the 3's cancel out. Cube root of y to the 1st power can't be done, so we're going to keep that just like this. 4 stays down here. This x to the negative 3rd power, that is being brought to the negative power, so it needs to move up to the numerator as a positive. This y stays here. And now we're going to take this top and we're going to combine like terms on the top. The 4's are going to cancel, so this becomes x times x to the 3rd, which is x to the 4th power. Okay, this becomes cube root of y, and this stays as y. All right, you can leave this in here. The only way you can get rid of that if you make this y to the 1st and then subtract 1/3 from that, but then you have 2/3 down the bottom, and you're not really supposed to leave a fraction down the bottom, although sometimes we have to. You start to end up going in a vicious circle. Okay, you're going to see that come up later as well.